good old histogram to deal with here, but what you don't do is start plotting frequency against time like so, like labeling this as 54 and drawing bars. That's not how you do it, because with a histogram, we draw the frequency density, which I should write in full, but I don't really have enough space. So we need to find the frequency density, and the frequency density is found by doing the frequency divided by the width. Why is that? Because it accounts for the fact then that the widths are different. Because if I've got a width of 40, that's much bigger than a width of 10, and so of course I'm going to kind of get more, it's going to be more scope to get results in that width. But if I divide by the width, then I'm essentially normalizing everything down. Right, let's work out the width. I think I'll do the width over here, in fact. So the width is going to be 10, 0 to 10, then 10 again, then 20, and then 40. So the frequency density is going to be 54 divided by 10, it's going to be 5.4. 50 divided by 10 is going to be 5. 44 divided by 20, well, how to do this without a calculator? What I can do is I can divide by 10 to give me 4.4, and then I can divide by 2. So I can just choose to do it bit by bit, and that's going to be 2.2. So a nice way to divide by 20, divide by 10, and then divide by 2, or divide by 2 and then by 10. 20 divided by 40 is the last one. That's going to be 2 over 4, or a half, or 0.5. And I've got my key values to be able to draw my histogram with. Right, I'm nearly there, but I need to decide how I label this. So I could go 1, 2, 3, 4, 5, but I'm sort of wasting space there. I want to use as much as I can, so it's going to make sense to go 1, 2, 3, 4, 5, and then I'll put a cheeky little 6 there. I don't really have enough space here, but that's okay. All right, let's do this. So I've got from 0 to 10, I've got 5.4. I can see that each little square is worth 0.1, so it's going to be like so. Then 0 to 20 is 5. 20 to 40 is 2.2. 40 to 80 is then 0.5, and that's my histogram. And now I see fully why we need to divide by the width, because before it looked like actually there's a lot of people that got between 20 and 40, but the fact is I was looking at a much bigger sort of catchment area as such, much bigger width. But when I divide by the width, I see actually, it's not as big as I first thought, for example. And if I did 20 to 80, then I'd have 64 people in it, and it would look like, oh yeah, loads of people were between 20 and 80. But the fact is that it's a much bigger width again, so it wouldn't really, properly describe what's going on, whereas dividing by the width does. So we've done that anyway. We've drawn the histogram. Kerry says the longest time that any of these students took to travel to school is 80 minutes. Is she correct? Well, we don't know. All we know is that 20 people took between 40 and 80. They might have taken 80, but we can't be sure. They might have all taken 41 minutes, for example, or they might be spread throughout. But essentially, we don't know. We can't be sure. Words to this effect. We only have grouped frequency. Kay makes another claim. She claims that 25% of all the students at this academy took more than 30 minutes to travel to school. Show how she might have worked out her claim. Well, for this, I would work out the number of people that took more than 30 minutes. And here's the thing, because frequency density is frequency divided by width, that means that frequency is frequency density times width. And that means the area of each bar is actually the frequency. So if I did 5.4 times 10, I would get back to my frequency. If I want to know how many people took more than 30 minutes, well, it's going to be these people, which I already have as 20. And then it's going to be half of the people between 20 and 40. So it's going to be 22 people here. I could have done 10 times 2.2 instead if I wanted to work out this. If it was three of the people, if it was like 37 to 40, and I could do 3 times 2.2 to work out the number of people approximately in that interval. So I'm just going to say that 42 people, 42 of the, okay, there's one thing, I don't have the total number of people, do I? So I need to, 168, it tells me. If I didn't have that, I could have added these up. So 42 of the 168 people, or students, I'll get away with people, took more than 30 minutes. This is, now I can write this as a fraction, 42 over 168, which becomes 21 over 84. Now, what goes into both of these? I think actually 21 goes into 84 4 times, so I can write a quarter, and finally 25% of them. So Kerry is right in this claim, and we've just essentially shown how she might have worked it out. State one assumption Kerry has made in making her claim. Okay, yeah, I didn't talk about this before, but it's again related to group frequency. It could have been that all the people in this interval took 25 minutes, in fact, or took 35 minutes. We don't know. But what we do when we find the mean of frequency tables, group frequency tables, or we deal with histograms, we assume there is an equal spread throughout each group. We don't know, but it could be that they all took 21 minutes. But when we do our calculations, we make this sort of approximation. That's what's looking for. State one assumption. The times are spread evenly through, I mean, it actually doesn't matter for the 40 to 80 whether they're spread evenly, but especially for the 30 to 40 interval, spread evenly through 30 to 40 interval.